from origin to the points defined like this. Area is Ni. So area will be 10 square plus it is 15K. Pi square, if you take common, 3 square, which is 15 square units. Pressure Bx A minus T square. So its dimensional formula of A must be T square. X is length. So pressure as a force per unit area, ml power minus 1 T power minus 2. So B must have a dimension formula is T power 4 by. A here is T square. So m T power minus 2. Angular momentum of a rolling body is R cross P. This is due to translatory motion plus I omega due to rotatory motion. So if you take this as R bar direction, momentum direction is this. R2V means R cross V direction will be inverse. That is, so this is MVR, R perpendicular. This is inverse. So here I omega, it is moving in anti-clockwise. Omega angular velocity, it is outwards. So it is pure rolling. V here is R omega. This R I will take it as radius of disk. I here is, here you take plus, this as minus. MR square omega by 1 is clockwise, other is anti-clockwise, sign difference, angular momentum. Instead of angular velocity like this, then it will have 3 mr square by 2. Here, pitch of screw gauge is distance moved by a spindle for one rotation. So, for complete rotations, it moves 2 mm. For one complete rotation, how much it moves means half m, half into 10 power minus. So least count of screw gauge is equal to pitch by number of divisions. So half into 10 power minus 3 by 100 divisions, 10 power minus 5. Second option is correct. A ball is hit at 30 degrees. So it has a kinetic energy of mu square. Whatever angle it is thrown, when it reaches highest point, it has only horizontal velocity vertical 0. Kinetic energy will be cos 30 root 3 by 2. It is 3k by 4. So 0.5 kg and the football begins to move with a velocity. The contact between the leg and football last here, the force acts for small interval of time. Is 1 by 50 seconds. So force is nothing but rate of change of momentum m times v minus u by. So final velocity 0, initial velocity. Mass is 0.5 into 50 into minus 10. So here you have that force is 25 into 10, 250. Here, block A is weighing 100 kg, rests on a block B. Here you have a block B. Once you apply a force, frictional force acts on this side. Since it is connected to other support, even there will be a friction between them. So let us say F1 and F2. Friction between A and B is how much? 0.25. So friction between B and surface, here the horizontal force necessary to move the block B means minimum force required is minimum force P required to move the block is equal to maximum frictional force. So here, if you consider surface and these two blocks, force of friction maximum will be mu s into n. That mu s here is mu1, n is normal reaction total weight. That is 200 plus 100, which is 300. So 100 G, which is 10 cube newtons. So this moment of block B is also opposed by block A because between them friction is there. So let us say this is F1, F2, right? Maximum frictional force. Mu S, mu2 into N, 1 by 4 into N in the sense normal reaction, its own weight. A is 100 kg into G. It is 250. Max total friction 100 plus 12 plus 250, 1250 newtons. Here, for maximum, path difference is n lambda. Sin theta here is, which implies n lies between, and here is, so including central maxima, number of maximas will be equal to 5. In hydrogen, here in this question, number of photons of all possible wavelengths are present in emission spectra. So the minimum number of hydrogen atom in the sample. So this question is not, he is not asking spectral lines. So for every transition, one photon is released, right? It will have a one state to other state with different wavelengths. It's a ground state, first excited state. When these five states are there, so hydrogen atom in it is in fifth state. So if it emits one photon, it can reach to uh, fourth state, or by emitting some other energy like this, different spectral lines are possible. Let us denote these spectral lines. So another possibility is from fourth state to third state, fourth to second, and fourth to one. Finally, let's, let us name this as that. So spectral lines means direct formula, that is 5 into 4 by 2. Now here you can observe spectral lines is 3, 4, 5, 6, 7, 8, 10, 10 spectral lines. But he is asking hydrogen atoms. So here fifth to fourth, again fourth to 3, 3 to 2, 2 to 1. All these transition can be done by one particular atom. That is, I'll write the order A, E, then H, I. So now these possibilities, it's J, right? Ruled out over. This can be done by one atom. About the next one, that is fifth to 3, and 5 to 3, and then 3 to 1. That is B to, here it is B and I. This can be done with, this transition can be done with another atom. Here one atom, here till now two atoms, totally 1, 2, 3, 4, 5, 6 spectral lines are over. Now 5 to 2, and this is already we have taken for other, 2 to 1 not possible. So 5 to 2, the transition can be done by another atom. Again, that is number, another is F, that is one atom, and another G to ground state, that is 4 to 1, another atom. So here totally for this transition C, one atom, for F, another atom, and for D, another atom, for G, another atom. Here four atoms, 2 plus 4, minimum number of atoms, hydrogen atoms in the sample space will be 6. So here breaking strength depends on stress, which is force per unit area. It is independent of length. Here F by pi r square. In one case it is 40 kg weight. In another case, what is breaking kg weight, we don't know. When radius is doubled, so Pi get cancelled. From here F is 160 G, that is 160 kg weight. During adiabatic process, in terms of PV, so in terms of pressure of a gas is proportional to cube of temperature. So I require a relation between P and T, which is nothing but T power gamma is constant. P T power gamma by taking 1 by gamma both sides, constant power 1 by gamma also. It's a constant. Here it is Pt power minus 3 is constant, which implies gamma here is gamma is 3 by 2. So 1.5. In here, 2 liter in a container heated. First 1 liter water weighs 1 kg. Power supplied 1 kilowatt at 27. So the lid of the container is open. Definitely, once it is open, some energy is rejected. So at what rate energy is rejected? 160 joule per second or 160 watt. So the net amount of heat will be 1 kilo, 1000 watt minus. So this much of watt. So energy left over, or this much of energy per unit time is uh, useful to increase the temperature. So that is energy is equal to ms delta T. 1 liter specific heat kilojoules delta T 21 into 10 power 4 joules. But he given power, that is 21 into 10 power 4. The time here is power utilized to increase the temperature is nothing but it is volume is 2 liters, right? Okay. Which is 500 seconds. There are two capacitors, 3 microfarad, 6 microfarad. They are charged to 12 volts. Then charge deposited 36 microcoulombs. This one is also charged to 12 volts. Charge deposited will be 12 into 6, 72 microcoulombs. So here, now what they did is, here positive terminal is connected to negative terminal of negative plate. Here positive plate is connected to negative plate. So in this process, discharging happens. So they'll have a same potential. Here it is 72 minus 72, 36 minus 36 coulombs. So since discharging happens, here some amount of charge flows from here to here. So then potential will be, so Q by C, that is 6, which is equal to, till having a same potential, 3 microfarad. Is Q minus 36. So in this case, 2Q minus 70. Q here is 48 microcoulombs. Now, once this is till attaining a same potential, charge transfer took place. Now common potential across each will be same thing. I will take, that is here coil of induction 300 millihenries and resistance 2 ohms. So here given is given resistance are equal to 2 ohms. Inductance is 300 millihenries. That is 300 into 10 power minus 3 henries, which is 0.3 henries. Right. And that inductor is connected to 2 voltage So the time in seconds which the current reaches half of the steady state. Suppose inductor is not connected, then only resistance is there. So immediately it reaches maximum current. Here 2 volts, 2 ohms means I hear 1 ampere current immediately within no time. So maximum current we can see in the circuit. When inductor is connected, so what will happen? So it initially, so once here I current flows through this inductor, EMF will be induced. That induced EMF will oppose the current. So initially this inductor offer a greater resistance. So with respect to time, it allows current. So till it reaches maximum steady state, that current which passes through the inductor keep on changes. So that how much current passes through the inductor changes according as 1 minus e power minus RT by L. So here it is what he is asking. So the time in seconds for which current reaches half of the maximum steady state here, that is maximum current is this, half of the maximum current. So 1 minus e power minus RT by L is half. E power minus RT by L is half 2 power minus 1. Taking power minus 1 both sides, I get, yes. Taking log both sides, we get log 2 to the base e. RT by L log E is log 2 to the base E. Here log E, it is to the base E, which is 1. RT by L is log 2 to the base. T here is L by R log 2 to the base. L here is 0.3 by 2. Log 2 to the base E is 0.693. Right. Here it is inductance 300 millihenries. So what you get here is 0.3 into 0.7, roughly 0.7, 0.3 into 0.7 will be 0.21, approximately by 2, which is 0.1 approximately. Here VA is the potential at A, VB is the potential at B. In steady state, so the difference between inductor and capacitor when they are connected in the circuit, in steady state, maximum current flows through the inductor. In capacitor, in steady state, no current flows through the circuit. In steady state, no current flows through the capacitor. Suppose here, if I consider this one resistor as well as capacitor in the circuit connected to the battery, suppose potential difference of, so battery is V. So let us take it as 0, it as V. So at this point also, because there is no resistance at P potential P, at Q potential 0. Slowly in the current flows through it, charge getting deposited. Over a period of time, here also potential difference is V between the plates of a capacitor L and M. So that is called steady state. If no more further charge gets deposited. So here maximum charge gets deposited, potential difference is V. So there is no current flows through this circuit. Now, even between P and Q, no current flows. Between P and Q, listen this statement properly. Between P and Q, no current flows. Still, there is a potential difference across the capacitor V volts. So don't think that once current is not flowing through AB, there won't be potential difference between AB. Right? In steady state, current will not flow. Still, there is a possibility that potential difference exists between A and B. Now we have to find out whether what is the potential difference between A and B. If that is 0, then obviously the potential difference across capacitor also 0. So now here in steady state, current is not flowing between C and D. Let us consider circuit A here. Here 2 ohms. Here it is battery is there. Here 2 ohms. Here I1 current flows through it. So here also I1, because this is steady state, no current flows through 3 microfarad capacitor. So across this, right. And I2 current flows through it. Again here same current. Here I1, here I2, here I1 plus I2 current flows through it. If I consider loop CAD, VC minus 2I1, Kirchhoff's second law, minus 5I1, minus 2 times I1 plus I2, plus 10, lower to higher, which is equal to VC, which implies minus 7 minus 9I1 minus 2I2 is minus 10. So 9I1 plus 2I2 is 10. If I consider CBD loop, that is CBDC loop, VC minus here resistance is 6 ohms. So 6I2, here what is the resistance? 15. 15I2 minus 2 times I1 plus I2 plus 10, which is equal to VC. From here, minus 23I2 minus 2I1 is minus 10. So 2I1 plus 23I2 is 10. Then take this as 1, both are equal to 10. If I compare, 9I1 plus 2I2 is 2I1 plus 23I2. So here I can say 7I1 is 21I2, which is I1 is 3I2. And I1 is 3I2. So then how to find out potential difference between VC minus 2I1, which is equal to VA. VC minus, if I consider this, what is that? 6I2 is equal to VD. So there is subtracting minus 2I1 plus 3I2, minus 2I1 plus 6I2, which is VA minus VD. Since here I1 is 3I2, so this becomes 0, which implies VA equal to VD. Our potential difference across, finally, conclusion here is potential difference between VA and VD is 0.